Rothamsted Research is the world's oldest agricultural research institute. Scientific research at Rothamsted happens at all scales, from the lab to the field and out at the landscape. Data is collected at all of these different scales, and as a statistician I get to be involved with a wide range of different projects. But how did I get here? Well, at school maths was always one of my favourite subjects. However, it was never really clear to me how I could make a career out of it. And certainly the traditional advice of finance or accountancy never particularly appealed to me. Nevertheless, I went to university and I did a maths degree, and it was here that I started to understand that I could use my quantitative skills to try and understand things about topics that really interested me. So, for example, part of my master's project was in developing models and analyses for trying to understand the link between air pollution, both temporally and spatially around a city, and link that through to hospital admissions associated with breathing difficulties. So it was here that I really started to understand that I could use my maths, and more specifically statistics, in order to try and gain understanding about topics that really were interesting to me. And in that case, it was science. So I went to do a PhD at the University of Warwick, and here I was working at the interface between statistics and molecular cell biology. Really, the key thing that I learnt here was that as technology advances, so does the type of data that we collect from such technologies. And what this means for us as statisticians is that the way in which we interpret and analyse such data also has to adapt. So after my PhD, I came to Rothamsted, and I'm working here as an applied statistician. But what does an applied statistician do? Well, to me, we turn data into information whilst also working on some really interesting and varied problems. So just to illustrate those, I've got a couple of examples to talk through, the first of which is to look at different ways of identifying insects. So aphids are a pest within the UK agricultural system, and they not only eat crops, but they also transmit diseases. However, they're really small, they're only a couple of millimetres long, and what we would really like is to have an automatic way of detecting which aphids are infecting which crops. So what we have here is a really technical looking experiment where we've got an upturned glass jar and aphids are freely flying through that glass jar. Inside here is a really cool sensor which is recording the sound of the flight of these aphids based on the shadow as they fly through the sensor. So what we're seeing is we can identify different recordings of these aphids, and what I've been doing is to try to identify different features of these recordings that help us to distinguish which species of aphid it was that went through the recording. So in this way, we're trying to take this data and turn it into useful characteristics of the flight patterns of these different aphids. Another example that I've worked on is within precision agriculture, and here we can see data that's collected in real time from combine harvesters, so we can look at how much wheat we're obtaining as we're going through the field at harvest. However, collecting this information year after year, we can start to see that different areas of the field are performing differently to others. And it's of interest to try and quantify this and to form different zones within the field that might inform how we can manage different areas of the field more precisely. So here what we're trying to do is to identify those zones, and unfortunately all of the maths and the statistics is hidden behind this arrow, but suffice it to say we're taking all of this data and information to try and give something useful and meaningful back to the farmer. So that's the general theme of what I do day to day. I'm taking data from all of these different projects, working at the different scales, and to try and turn that into some useful information for end users. And although that's the crux of what I do day to day, I have to say I've been incredibly fortunate in that my job is not completely desk bound. I've been able to travel the world, going from Canada to Australia and Africa in between, giving presentations, attending workshops and conferences, and more general outreach programs. So although the path I've taken has been relatively direct, doing maths at school, A-levels, university, I would like to say it's definitely not the only way of getting here, and it's never too late to change direction.